In the last lecture, we had discussed about some very basic concepts and testing. We were discussing about the test cases, test data, and we had said that for every software, a set of test cases are designed carefully, and this is known as the test suite. And for each test case, the system we execute the software using the test data, and each test case is typically contains three parts: the test data, the state at which the system should be there when the test input is given, and the expected output. So, to execute the software with a test case, we first put the software in the required state S. For example, some book record might have to be created, some member record might have to be created, books issued for a library software. And once it is there in the required state, then we give the input and then observe the output, and we note this, the observed, we observe the output and note our conclusion on a test report. Let us see how a test report is organized. Typically, each test case has a number. It becomes easier to see that which test case got executed, because once the system fails, the developers needs to reproduce the bug. So, a test case can uniquely identify which test case they should execute, who had written the test case, the author, the purpose of the test case, like which functionality or performance, etc., it is designed to test, the test data or the test input, the expected output. Okay, precondition is the state at which the system should be there, test input, expected output, and the state at which the system should be left after the test execution completes. And once the test output is produced, the testers observe the output and then they write their analysis of the observed output. They write the test execution date, person executing the test, they observe the pass fail, whether it has passed the test case or it failed the test case, and if failed, they write what exactly happened, what was observed during the failure, did it crash, did it produce a wrong result, did it go into an infinite loop, and so on. And then there is another field, because the developers need to fix each of the failure cases of test cases. So, there is a fixed status field where the developers can record whether they have fixed it or not yet fixed. Now, let us see the composition of the test team, that is, when organization develops software, what types of testers does it need? We saw that there are many activities during testing. The different activities of testing are test planning, test scenario and test case design, test scenario design, test case design. We will see what is the difference between a test scenario and test case. But roughly speaking, a test scenario is a abstract description of a test case. For example, we might say that all paths should be covered, or a specific path needs to be covered. So, that is a test scenario, that a specific path in the program needs to be executed. Whereas, the test case is more concrete than the test scenario, in the sense that we provide the test data, input data for which that specific path will be covered. Test execution, test result analysis, test tool uses, and so on. So, there are many activities during testing, and let us see what are the kind of human resource we need for the test team. For test planning, this is done by experienced people. Test scenario design and test case design, this also experienced qualified people. Test execution can be done by semi experienced to inexperienced persons, depending on the software that is being tested. Test result analysis, this is by experienced people, and test tool uses by experienced people, and also testing, several other people participate like users, industry experts, and so on. So, the composition of the test team is of various types of personnel, because different activities in testing require different levels of expertise. But let us now answer a very fundamental question: why do we need to design test cases? Can't we just test it with all possible inputs? Because if we could test with all possible inputs, then we can be sure that the software is working fine. But why go about only designing few test cases and then execute those? The answer to this question is that even for a very small, trivial, almost trivial software, if we want to test it exhaustively, it is extremely large number of test cases, trillions of test cases can be designed for exhaustive testing, and the input data domain is extremely large, and it will take thousands or millions of years to even test a simple program. We will see through an example that why this is so. We will take a simple program and see how many test cases are required to test it for all possible test inputs. Since it is impractical to test with all possible inputs, we need to develop a optimal test suite. This optimal test suite should be of reasonable size, and it should be able to uncover the largest or the maximal number of errors. Also, we cannot give random data, because random data has a problem that we might give the same data again, or we might give a data which detects a similar problem, similar bug than the test cases that were given earlier. We will see through an example. So, even though we might test a software using 1000 test cases, a very small function, let us say we tested with 1000 test cases, but still if we are doing it in random testing, we cannot be sure that it has been tested well, because most of the test cases that have been generated randomly may be detecting the already detected bugs in that test suite. So, if the test cases are generated randomly, then claiming that we tested it using a large number of test cases does not indicate truly the effectiveness of testing. We might have tested using a million test cases, but if it is just random test cases, then it does not mean that most of the bugs have been eliminated. Might just have detected a very small number of bugs, if at all. Now, let us see how to design test cases. So, testing using random test cases does not mean that the system is tested well. Most of the problems have been uncovered. Let us convince ourselves with a small example. Let us say we have a function, name of the function is find max, and the parameters are two integer parameters x and y, and the function, let us say, is a trivial function which just returns the larger of the two. The code is just 2 lines, but then let us say in this 2-line code we have made a mistake. If x greater than y, max equal to x, else max equal to, it should have been y, but by mistake programmer has written max equal to x. Now, if we give two test cases, okay, for the test cases we have only represented the test data, omitted the other for conciseness and understandability. Now, the test suite where we test it with x is equal to 3, y equal to 2, that is the first statement is executed, and x is equal to 2, y equal to 3, that is the second statement is executed, we can detect the bug, because if x greater than y, then we should report that the max is x, otherwise we should report max is equal to y. But then here the bug will get exposed. But let us say we have a larger test suite where only the first statement is always executed. Even if we have 1,000 test cases like this, where x is larger than y, then only the first statement is executed, and the bug that is there in the second statement will not be detected. So, that example should convince us that if we have a large number of random test cases, that does not mean that we have tested the software well. Now, let us see what exactly is a test plan, because before testing starts, the test plan is prepared. The contents of the test plan are that for a certain testing to be carried out, what are the features to be tested, that is what features have been already completed and those need to be tested now, what features not to be tested, maybe those features are still undergoing development and need not be tested, the test strategies that are deployed. We will see that there are many strategies, the black box and white box, and also there are several strategies of black box testing and several strategies for white box testing. Test suspension criteria, that is if a fatal error, let us say crash is observed, then we may not be able to run the other test cases, and then we must suspend the testing, and then ask the developers to fix the problem before the other testing can be done. The test suspension criteria says that when, under which situation the test execution can be suspended, and the developers asked to fix the bugs before the testing is resumed. Stopping criteria, this says that as the testing goes on, progressively less bugs are detected, and how long to test. The test effort, is what is the planned test effort that is required, how many people, testers, how many testers for how many days, and so on. The test schedule is about when what type of testing will be done. Now, let us see how to go about designing test cases. One very important concept here is that when we design test cases, each of our test case should target to detect different types of faults or bugs. No two test cases should actually target the same bug, because that will only increase the number of test cases without reducing the bugs in the code. Now, let us see the test strategy. So far we have been saying that there are many test strategies, and these can be considered as bug filters and so on. Now, let us see at a very overview level what are the test strategies. The test strategy is basically a type of test to be deployed. There are many types of test strategies, as we will see subsequently. The white box and black box is a gross characterization of the test strategies, but then there are many types of white box strategies and many types of black box strategies. But given that there are dozens of strategies to be deployed for testing, the testers have to plan how much time should be devoted for which type of testing. We will see how to plan for the time, but then for the two types of testing, the black box, these are also called as the usage based, because these are designed based on the customer's usage data. The white box, these are guided by the results of the black box, because the black box tests are performed first. So, if we find that some problems, many problems are being detected in some part of the software, we need to do more thorough white box testing on that part, and that is the reason we can say that the white box testing results are normally guided by the black box testing results. Now, let us see that this is the past bug data for some software. Now, let us say we are planning to develop some additional parts for the software. Now, how much testing we should do? Let us say from the previous one we had seen that reviews get 10% of the bugs, unit testing gets about 40% of the bugs, integration testing does about 25%, system testing gets about 15%, and the customer reported is about 10%. Now, we want to do a new release where we have developed some parts of the software. So, how much, let us say we want to release it within a week, and let us say total test hours that is available to us, because there are maybe 10 testers working, maybe let us say 200 hours of testing. Then for which type of testing, review, unit testing, integration, system and customer reported, how much time should be there? How much test time should be allocated for unit testing, for integration testing? It is common sense, it is nothing very profound about this. Since unit testing is detecting the largest percentage of bugs, that is 40%, we need to spend more time on unit testing, and to be fair, we should spend 40% of time that we have, let us say 7 days and let us say 100 man hours, we should spend 40% of that doing unit test, 10% on reviews, 25% on integration testing, and 15% on the system testing. Now, let us say that we have past bug data available to us, and we had deployed various types of test strategies. Now, let us say we have written how many bugs were detected by different test strategies. Let us say strategy 1 detected 50% of the bugs, strategy 2 30%, strategy 3 10%, and rest were customer reported. So, if we want to do a new release for this software, how much time do we plan to do the different types of testing? Test technique 1 detected 50%, test technique 2 30%, test technique 3 10%. Again, common sense that the test technique 1 is very effective, detecting nearly half of the bug, and therefore, we must spend 50% of the time doing this very thoroughly, 30% of the time for test technique 2. Test technique 3 is not that effective, detected only 10% of the problems. So, 10% of time to that. Now, let us say we have another set of data. Let us say based on our unit testing, we found that the module 6 has the maximum number of bugs. Next is module 1 and module 4, and the lowest is module 3. Now, we want to have one more release of this, where we have made changes in different parts of the software. So, where do we spend how much time? Again, common sense is that module 6 is the one where maximum number of problems are detected. So, maybe more problems are there, and therefore, we need to spend proportionately much larger time on M6, and then M1, M4 and M3 we need to spend the least amount of time. Now, let us see some details of unit testing. So far, we have been looking at some very basic concepts. Now, let us look at more details on unit testing. But before we start discussing detailed way of designing test cases for unit testing, let us be clear about one aspect, one question that we might have, that can we just eliminate unit testing and do a thorough integration and system testing? Unit testing is carried out after coding is complete and the code has been successfully compiled, and that situation we do the unit testing, and we cannot really eliminate unit testing because it is a very effective technique, because it reduces the debugging effort. If we do not do unit testing, we do a thorough integration and system testing, then the debugging effort will be much more. Let us understand why. Let us say these are all different units that are shown here, and we just did not do a unit testing, and there was, let us say, assume a bug was there, and then we ran several test cases, and some of the test cases they failed. But then to debug, we need to check each and every of these unit, or maybe at least those units which got executed during the execution of that failed test case. But in unit testing, when we do unit testing, we know that the bug has to be within that unit. We do not have to look at the other units, and that is the reason why debugging effort for problem reported during unit testing is much less compared to when unit testing is not done and we directly go for system testing. In system testing, the errors are much more difficult to track down, that is localize where is the bug, and therefore the debugging cost increases substantially. This is another basic concept in unit testing. We use the term unit testing when we either execute an individual method and test it. Unit testing may be applied at the level of modules. We just unit test a module. We might unit test a class in object oriented code, or may unit test a component in a component based software. But the problem here is that if we take up a unit and we want to execute it, but then there must be some software which supplies the data, invokes that unit, and similarly the unit that we are testing, it might need to invoke other units. There might be call to other functions and so on. And since we are testing the unit in isolation, we need to have these two small code written. The driver is the one which will call the unit and supply the necessary data, and the stubs are the functions, some dummy functions which the unit will call. So, the driver and stubs have to be written during unit testing. The driver and stub are two small software. So, the tester has to write some code here. The driver simulates the behavior of the function that should call the unit and also supply the necessary data, the test data. The stub, on the other hand, these are the functions that need to be called by the unit. We can represent the same thing in this form, that in order to do unit testing for some unit, the tester has to write two small software. One is the driver, which calls the unit under test and also supplies it the necessary data, and also if the unit needs to access some global data, then it provides the global variables or global data to the unit, and also needs to write the stub which the procedure under test, that is the unit, needs to call. So, for unit testing we need the drivers and stubs to be written before the unit testing can be carried out. Now, let us have a small quiz. So far we looked at unit testing in this lecture, and we saw that in unit testing we just isolate one unit and then test it by designing some test data, and we write the driver and stub for that unit. But then unit testing can be considered as which one of the following types of activity? Is it a verification activity or a validation activity? The answer is that it is a verification activity. Unit testing is a verification activity, because by definition validation is checking the full developed software against its requirements. In unit testing we do not do that, we just take out a small unit and then test it against its functional requirement for that unit. So, unit testing is not validation testing, it is a verification testing. we are almost at the end of this lecture. We will stop at this point and then continue in the next lecture. Thank you.